When we do the sorting, actually we have many different algorithms. Like earlier I showed you, we will revisit the sorting algorithm in the future class, no matter it's your next class, Advanced C++ in 165, or Data Structure class in 210. We have so many different sorting algorithms. Then we were using different way to do the implementation. So in this class, after the nested for loop sorting, I want to show you the bubble sort. So sometimes why we call that bubble sort? Because the bubble, right? Remember when you see the bubble from our from the water, you have bubble came up. So that's why, because the bubble is light. So that's why when we do the bubble sorting, bubble sort, that means the first iteration you have your heaviest one. So you have your greatest value will be on the bottom. Then afterward, you see your light value will be go up one by one. So that's why we call the bubble sort. So the bubble sort concept is you compare stuff from the first two elements. So the first two elements, if they are, the first element is greater than the second one, we swap. So remember, when we talk about sorting, if we didn't specify, we always do the ascending order. So ascending order means low to high. So when you want to compare the bubble sort, we always compare stuff from the first two elements. We want to see if they are in the right order. If not, we swap. Otherwise, we move to next two elements. You move down only one element, you compare the second and third. So then if they are not in the right order, we will swap. So that's why here they say exchange if necessary. So after you finish the first iteration from beginning to the end, you will continue to the next iteration. So that's why you see when we do the first iteration, we start from beginning to the end. Then we compare two elements one by one. After we finish, each iteration have the greatest value at the end. So the next time when we do the array again, we will still start from the first two elements, but we will do until the last two elements. So that's why here, after your all the iteration finish, you will have that in the right order. So let's see here how they will work on that. We just, for example, we have 4 elements here. So what they do is, like we say, we have the first two elements first. So 17 and 23, are they in the right order? Right, because if we don't specify, we mean low to high. So 17 and 23, they are correct. So we do nothing. Then we do the next two elements. So the next two elements is 23 and the 5, right? Are they in the right order? No, because low to high. So 5 is smaller than 23, but 5 is in the later, is after the 23. So if they are not in right order, we swap. So we will swap 5 and 23. So after you swap 5 and 23, so see here, you will see these two we need to swap. So after you swap, 23 is here. Then we compare 23 and 11. The same thing, 23 and 11, they are not in the right order, right? So that's why they swap. So afterward, you will see 23 will be here. So that's why we call each iteration after you're done, the heavy value will be at the end. So after we have 23 in the right order, good. Then we go another iteration. We still start from 17. But earlier from our iteration, remember 23 is in the right location. So that's why here we still start from the first two elements. Then you will see now 17 and the 5. Are they in the right location? Are they in the right order? No, right? Because 17 is greater than 5. So that's why we swap. Okay, so after you swap, 17 is here. So then we compare 17 and 11. Again, 17 and 11, 17 should be here, so we swap. So after we done, actually, so you see the second iteration, I don't need to touch 23 because we know 23 already in the right order. So after we finish the second iteration, 17 will be here. Okay, continue. So after we done the second iteration, 17 and 23 in the right location. So then we only need to check the first two again. So the first two is 5 and 11, right? They are in the right order. So then we finish. So this one we call the bubble sort. Bubble sort, each iteration we will go over until the end. But the second iteration we only need to, we can ignore the last one, we only go to the rest of that. So that's why here you will see in the bubble sort algorithm, when we do the implementation, you see there will be similar function. Earlier we called the sorting array, right? So since here we're using the bubble sort, we call bubble sort function. So this bubble sort function, you pass in an array. We don't need to do the constant pass because we need to update the array data, but I need to know the size. So then here we will have, again, you still have two for loop. So then the outer loop, we will start from size minus 1. Then the maximum element greater than 0. Then maximum element decrement by 1. So this one is, we just know how many elements we need to do. You see the first iteration, I do all the elements. But the next iteration, I only do we will not go into the end. We do without the last one. Then you see each iteration, we will have one less element include. So that's the outer loop. Your maximum element start from size minus 1. That means we will go through to the end until maximum element greater than 0. Then you decrement by 1. So then remember, inner loop is our comparison. We start from index equal to 0, index less than the max element. So then you see, remember, we always check the first two, right? So we do the index start from 0. I check index plus 1. So if the beginning index greater than the next one, that means you are not in the right order. So then we swap. So earlier when we show you the swap function, we show you the swap action, we didn't write the function. So if you want, we can write the swap into the function. So which two value you want to swap? You pass in the integer location. But when we write swap into a function, you see, you are not passing by copy. You passing by reference. So that's why when we reassign the data, they will reflect here. So let me detail to talk about swap. So the swap actually, right here, you only passing me A and B, right? Right, you only passing me A and B. Right, here is A. But you see, when you're passing me A, to know very careful when we do the swap in computer world. You have A and B, but they only occupy two memory locations. If I want to overwrite their value, right, later in B value, they need to switch, right? So that's why if I just write the A value equal to the B location, you see, then B location become A. Yeah, you see, the value of B is gone. So that's why when we do the swap, it's very dangerous. You don't have not the third value because you only have two memory locations. When you have one memory location being overwritten from another value, that value is gone. So that's why here, when we want to assign to swap A and B, we need the temp. This temp actually is just temporary. You see, temp equal to A. I temporarily holding the value in A in the temp location. So after I have this one holding, right, then I can assign A equal to B. Then afterward, I can assign a value to the old. So that's why afterward they can be successfully to exchange the value. So you need to be careful in the real life, right? You do the exchange, you just exchange, right? But in the computer world, we cannot just exchange with two locations. Because in the real world, you say 50, a number they exchange, right? That's because in your brain, you remember the other value. So that's why you just exchange them. But in the computer world, whenever we want to exchange two values, we need to have the third location to temporarily to save one of those values. So that's why we can do the swap. And also when you want to implement the swap function, we need to pass in by reference. So that's why when we update the value in these two memory locations, when they're coming back to the calling function, the memory location value being updated. So this one is how we implement the bubble sort function. And I also more detail to explain the swap function. I don't have a chance to talk about in the previous video. So that's our bubble sort. A lot of times students will ask why we need to learn so many different sorting. So one reason is different sort, they have different algorithm and they have different runtime efficient. So then when we deal with the small data, like now your array element may be just 10, different sorting algorithm may not reflect the runtime efficiency. But in the future, like in COMSC110 in data structure class, we will deal with the big data. So when we talk about big data, that means you have 1 million data. You have 1 billion data you want to be in the sorted order. So if at that time we still try to using the nested for loop or bubble sort or the selection sort and insertion sort, they all implement in two nested for loop. They all are in the big O(n) square runtime efficiency. So when they deal with the big data, the runtime will be super long. So then we will introduce you a couple more efficient sorting so we can bring down the runtime. So that's our sorting from chapter 8.